Now this is all presented as I wrote it out in the preceding, but I'm going to give you a quicker version right now because that's probably all you need. Okay, so first thing we want to do, and I've written down into the area of the graph here, but I started out with a set of coordinate axes, and I have the point 1, 1 about halfway between here and here, and about halfway between here and here. So it's at about the middle of the graph area. So that's going to be our point 1, 1, and we're going to construct various y equals x to the p power functions. Again, if x is 1, y is 1, so that 1, 1 will be in the graph of any of these functions. So we want to start by sketching on the same set of coordinate axes. Start out with the picture I have here basically, and sketch y equals x to the p for y factors 1 half, 3 halves, 2, 5 halves, and 7 halves. Now you've already constructed the graphs for 3 halves and 5 halves, so you can reconstruct those, but then do the graphs for 1 half, 2, and 7 halves as well. So you can see how these various curves relate. And then I want you to estimate the curves for y values, for y factors, 3 and 4. Okay? Y factor 3 and y factor 4. I don't want you to construct those. I want you to estimate them based on the picture you have that shows these 5 curves. That should be fairly straightforward, but I'm going to let you think about exactly how you might approach that. Might be obvious, you might have to think about it for a couple of minutes. Okay, then, having done all this, for the factor 3 curve, I want you to estimate the y values for x values 1/4, 1 half, and 2. Okay? Then, having made those estimates, I want you to carefully construct the factor 3 curve. Okay, so you've estimated the factor 3 curve based on these graphs, but I want you to actually construct it this time, and then estimate f of 1/4, f of 1 half, and f of 2, where f of x is the function for the factor 3 curve. So really I'm saying the same thing here that I said here. Though here you're going to use your estimated curve, here you're going to use your carefully constructed curve. F of 1/4 means the y value when x equals 1/4, obviously. Okay, now we're going to go on, and I'm actually going to let you do some calculations. You're not going to have to do any real arithmetic because you're going to have to use your calculator for all of these calculations, and the calculator is not necessarily an evil thing, it's just often put to evil use. And here we're making good use of it. So the factor 3 curve represents what? Y equals f of x equals x to the log 3 over log 2. Okay. Why is that? Well, hopefully you've proved that by now, but not everybody will have proved it. We can accept it because it's been stated previously that the power p is just the log of your y factor divided by the log of 2. We can use that. We can use that without proving it, but you have a much tighter and deeper understanding if you have proven it, so it's very much to your credit if you have, but if you haven't, you still have some fairly challenging stuff to do, and you don't have to feel too badly about that. Okay, then we want to evaluate this f of x function here for x equals 1/4, 1 half, and 2. You can easily do that using your calculator. And then we want to compare that with the previous results. Now, I didn't say down here, we want to compare how you did with your carefully constructed graph with your estimated factor 3 curve. How do these two compare? Do you have the same values? Well, you're not going to get exactly the same values. If you carefully construct the curve and do everything carefully, you're going to get somewhat different values than you would from this curve, because in the first place it's 2 different sketches, and in the second place it's well, it's just very likely that you're not going to position this curve exactly right. If you do this one really well, then you're going to have a pretty good positioning of this curve. So, and now we're going to actually calculate those values so that you compare this with the actual values that you should have gotten if you did it exactly right. Okay? Now, a couple more things. What about the factor 2 curve? The factor 2 curve, you probably noticed, has a pretty specific shape, very specific shape. What's the shape And can you prove that it really, if it's constructed with absolute precision, would really have the shape you conjecture? Okay? Then there's a difference between the factor 1/2 curve and the others. What's that difference? Very clear difference. And then what is the limiting value of y as x approaches 0? That's for the factor 1/2 curve. Okay, a couple of other things we want to do just to get a general picture of what is really, this is a function family, and we're developing it in not the traditional way, but in a way that avoids a lot of calculation and reliance on arithmetic because of misuse of the calculator. People generally don't have the arithmetic skills to really understand what they're doing in the traditional approach. Okay, so we want to sketch the factor 1 curve. Okay, so I want you to add that to this. And then, why is the factor 0 curve undefinable unless 0, 0 is declared to be the starting point? In other words, if we start with 1, 1, as we have with all the others, what's weird about the factor 0 curve? And is it really a curve even? Okay, now, when I said carefully construct your factor 3 curve, I should have said at that point, do this on a separate graph. Don't try to slop this into the same graph. In the first place, you would be influenced by everything else that's on this graph. It's going to get way too cluttered. But the factor 1 curve should go on the same set of axes. And you're playing around with the factor 0, 0 curve, could go just about anywhere. Okay, good luck. I'll do some discussion of these problems, but you should do the problems without looking at the discussion.